Good evening to all. Although I have already created and posted few videos on centrifugal compressor and which are available with my channel. However, I have started creating videos considering all the aspect, I mean from the basics to design and performance of centrifugal compressor. So this is the first video in this kind and which is related to centrifugal compressor and its association with the plant process. So I hope this video is going to be very interesting, and so I request please keep watching until the end and subscribe my channel, and don't forget to hit the bell icon. Thank you. And so let's begin with this video for centrifugal compressor and its association with the plant process. This is a centrifugal compressor, single stage centrifugal compressor. This is suction of centrifugal compressor and this is discharge. So centrifugal compressor is a machine. If somebody asks what is centrifugal compressor, so we can say it's a machine and used for the generation of pressure. This is the main function of centrifugal compressor. And certainly the compressor uses air or gas. In fact, air is also considered gas. So you can call it centrifugal machine. Centrifugal compressor is a machine used for the pressure generation of gas. The pressure rise of gas or air occurs in centrifugal compressor is mainly due to centrifugal action and diffusion process. Centrifugal action means the wheel is rotating, impeller is rotating, and because of this, gas is also rotating, and which creates centrifugal action. Diffusion has two processes. One, while the gas moving through the blade, area increases and diffusion occurs. So this is one part. Second part, after obtaining high kinetic energy at impeller outlet, that high kinetic energy gas needs to be you know diffused in vaneless diffuser, vane diffuser, and casing. So there is a diffusion. So diffusion occurs in impeller itself as well as outside the impeller, that is in diffuser and casing. During the process of pressure rise, temperature rise also occurs in compressor. Since the process of compressor is adiabatic or isentropic or polytropic, there are two processes considered in compressor, that is one is isentropic or adiabatic, another is a polytropic. And because of the compression, temperature rise also occurs. So if user wants high pressure and cool gas, then high pressure and high temperature gas coming out from the compressor needs to be cooled down in the heat exchanger or cooler. Cooler is also sometimes called a heat exchanger. So the temperature of the gas cools down after the heat exchanger and pressure remains almost higher because there is a very little pressure drop in the heat exchanger. In a special case, if user wants warm gas high pressure, then cooler is not required. So this is the basic purpose of centrifugal compression. Now next question is why multi-stage compressor is needed. You can see this is a two-stage compressor is shown here. This is first stage, this is second stage. Stage is a type, a stage compressor means one stage means single stage, another stage, this is similar like compressor. So it is called multi-stage, one stage, two stage, it is shown. So gas comes here, this is going out, then comes here, then goes out. Of course, based on requirement, this high pressure, high temperature gas needs to be cooled down before coming here. That is second stage. So now question comes from why multi-stage compressor is needed. If user wants very high pressure, then single stage centrifugal compressor cannot generate that much pressure. Reason is compressor can generate pressure rise based on the impeller outer tip speed, and it has related to impeller outlet diameter and speed, which is expressed as pi d n by 60, which is meter per second, where d is outer diameter in meter and n is rpm, speed in rpm. But there is a limitation of material construction of impeller, that the tip speed of impeller cannot increase beyond certain value, because it is responsible for high pressure, but there is a limitation. Else impeller can damage due to very high stress develop due to high centrifugal force. Typically, centrifugal compressor can raise pressure ratio of 2.5 to 3 for air application, depending upon the material of impeller. If the mole weight of gas is lower, then pressure rise will also be lowered, like case of ethylene service or hydrocarbon gas molecular weight is, let's say, 16 17, then pressure rise cannot be 2.5 or 3, it will be very less. Titanium is having highest tip speed, followed by stainless steel material and others materials, and that is reason multi-stage compressor is needed. You understood? Because if somebody wants pressure of 8 bar, then for air application, so single stage compressor cannot generate 8 bar with single stage, because for air application it can raise up to, let's say, pressure ratio of 2.5, so 1 to 2.5. Then you need another stage, you need another stage. That is why multi-stage is needed if the pressure requirement is more. Now, why interstage cooling of compressor is required? Now, this is another aspect or requirement. See, look at this is a multi-stage compressor. In between is an interstage cooler. So, high pressure, high temperature gas of, let's say, first stage comes out and goes to next stage, and before that it has to be cooled down in a heat exchanger. So you see a lot of heat exchangers are given here. So outlet of one state goes to cooler, where the pressure drop is a very less, but temperature drop occurs, and this temperature drop, then high pressure cool gas going to the next stage. Then why it is required? In case of multi-stage compressor, outlet pressure of gas becomes hot. You know that needs to be cooled down before going to the higher stage of compression. A stage compressor means one stage, two stage is type of matlab is a single stage, double stage, triple stage means number of stages, means number of compressors. This is done because of mainly two reasons. One reason is power saving in compressor. So why interstage cooling is required? One reason is power saving, and why, in fact, the cold gas is compressed. Let's say if cold gas is compressed in compressor, then power consumption by the by the compressor will be lower. So if goes low temperature gas in higher stage, then compression power consumption for the next stage will be lower. Second reason is that if the hot gas is compressed in the next stage, then temperature keep on increasing. Let's say if the inlet of first is 30 degree, outlet is 100 degree, then 100 degree, if it is again compressed to the another stage, it becomes, let's say, 200 degree, and so keep on increasing. Then material of then material of compressor cannot sustain that high temperature, otherwise it can fail, and that is the reason the interstage cooling is required. So one reason is power saving, another reason is limitation of material to withstand high temperature. And because of this, interstage cooling of compressor is required. Now the multi-stage, different impeller diameter and speed. You'll see in case of then we'll see, as multi-stage compressor diameter start decreasing and speed increasing, particularly in in a integral gear type arrangement. In case of multi-stage compressor, impeller diameter of first stage compressor is largest. In higher compressor stages, the diameter of impeller starts decreasing, and this is due to the fact that the pressure increases in compressor stages. Actual volumetric flow rate starts decreasing, and so a smaller diameter can handle that flow. It is to be noted that the mass flow rate remains same in multi-stage compressor if there is no condensation in the stages. However, in case of atmospheric air handling compressor, as there is a condensation in compressor stages, and so mass flow rate slightly starts decreasing in stages. In integral gear arrangement, diameter of impeller starts decreasing and the speed of impeller starts increasing in higher stages to achieve best efficiency. One reason is volumetric flow starts decreasing, that is why smaller volume or smaller diameter can handle that much volume of gas. Please note that the mass flow rate remains same for all stages because all stages are in the series, and speed is also increasing because we have to match the specific speed to have a best efficiency, and that is the reason in integral gear arrangement you will see that diameter starts decreasing and speed increases for higher stages. Now multi-staging arrangements. There are broadly two arrangements through which multi-stage compressor can be arranged. One is called IG compressor arrangement or integrally geared compressor, and another is a barrel type or inline compressor. So there are broadly two arrangements through which multi-stage can be arranged. Now let's discuss about integrally geared compressor. You look at this is a single stage. This is bull gear which is connected to the motor or a steam turbine which drives the shaft gear here, and then which is connected to impeller. So this is outlet. This is suction of compressor. This is outlet of compressor, and this is a gearbox. So in this arrangement, the main drive shaft, which is called bull gear, this is bull gear. This is number of teeth is more than shaft gear, which is connected to the driver or motor steam turbine. The bull gear drives the other pinion through helical gear. You can see here this is arrangement of helical gear with certain speed ratio. The number of gears on the bull gear is more than shaft, and so speed of shaft is higher than bull gear because gear ratio is inversely proportional to the speed. So if a smaller the number of gears will have more speed. So gear ratio is selected based on the speed requirement of the shaft. Impeller or impellers are attached to the shaft. You can see here it is not here, but in this side the impeller is connected here. A bull gear can drive maximum 4 shafts, 1, 2 on top, on other is bottom. So there are 4 pinion or 4 shaft can be driven by bull gear maximum. If each shaft has two number of impeller, let's say 1 and 2, so there will be 8 impellers can be driven by bull gear. So 8 stages of compressor is possible. Now this is a single stage compressor. Bull gear, this is bull gear, this suction, this is discharge. You can see this is a bull gear, this is shaft gear which is connected to mesh within helical gears which drives this, and impellers can be connected here and here. This is 3-stage compressor. Each stage, this is a stage compressor. So this is the first stage. This is bull gear which is connected to either main motor or steam turbine. This drives 1 and 2 shaft, and in one shaft there are 2 impellers are connected, and another shaft it is 1. So total 1, 2, 3 stage compressor. This is first stage. So gas comes here, and after pressurization comes out. Certainly it is not shown. It goes to intercooler where high pressure, high temperature gas becomes low temperature. Then comes here. This is second stage. Then comes out here. Again it goes to another cooler where it cools down, comes here, and then finally comes here, and then again it will goes to cooler. After call it after cooler, it is again a heat exchanger, and then finally go to the process requirement. You can see the views. This bull gear drives two pinions, one and two. Pinion means shaft. One, two, three. Now eight stages is possible. You can see this is bull gear again shown. This is bull gear. One, two, three, four, five, six, seven, eight. So one, one, two, three, and four. So both side one on top, another is bottom. So total four shafts, and each shaft will have two impellers. So total eight impellers or eight stages of compressors possible in integrally geared compression. Now another type is a inline compressor or barrel type compressor. You can see the single shaft, number of stages are attached. In this arrangement, all the impellers are attached to single shaft, and shaft is connected to driver, motor or steam turbine directly or through a speed gear ratio. In this arrangement, the speed of each impeller remains same as all impellers are connected to same shaft. You can see this is three impellers, four impellers shown here, and these are the casing, lower portion of casing of inline compressor or barrel type compressor. Now, centrifugal compressor with plant process, how it is connected or how it is associated with the plant process. Typically, centrifugal compressor broadly has been categorized in two categories. One is called atmospheric handling air handling compressor. Another is a process gas handling compressor. So let's discuss a little bit more about what are the how compressor is associated with atmospheric air handling compressor. Another is a process gas handling compressor. This is arrangement for atmospheric air handling compressor. That means this is atmosphere. It takes air is taking from atmosphere, open atmosphere, and so air filter is required to clean the air. So clean air should come inside the compressor. Before that, inlet guide vane is installed, which is closer to compressor, and then it goes to check valve. Is nothing but it's a valve which will allow direction of gas in only one in this direction. It will not allow to backside, and then finally discharge check valve and then go to plant process. And before this check valve, you see there is anti-surge control valve is installed to protect the compressor in case of surge control. So this is a typical arrangement of this is compressor. Compressor can be single stage or multi-stage, which is shown here. So atmospheric air has to be pass through the air that has for the cleaning purpose. Function of IGB is to control the flow, and what is purpose of anti-surge control valve? It is a purpose of mainly for to take care of surge control of the compressor, and also this is used for the process application. In normal case, this valve remains closed, so air takes compressor takes air from atmosphere and it discharges to the process. Now another application is a gas compressor plant process, where you will see the gas, the compressor takes gas from the plant process. So you need a one isolation valve that is called the suction valve, then a stainer that has to be cleaned. The process gas, if it is coming, that has to be cleaned. Then inlet guide vane, and then this compressor. Compressor can be single stage or can be multi-stage. Then check valve, and then discharge block valve, and then finally goes to the process. But there is one anti-surge valve, same location, but it is again back to suction of compressor. Since the process gas is can be hazardous and it is not safe to vent into the atmosphere, it has to be recirculated back to upstream side of inlet guide vane. And the main purpose of this is for taking the surge control. If compressor is going to surge, that has to be taken care. The valve will open up, so the gas will be returned back to suction to make up as per requirement. So in the gas process, in the gas compressor, you will see the suction valve and discharge valve both are there to isolate the machine whole system if it is not in operation. Then what is the inlet guide vane IGV? The main function of IGV is controls the flow and pressure. If you open more IGB, more flow you will achieve, more pressure you will achieve. You can see this is IGB, this is actuator. IGB is shown here. This is another type of arrangement of IGB, which is blade is shown here, is also IGB shown. So various types of IGB is shown here. This is actual machine. Actuator is connected to IGB for operation purpose. The blades, these are blades, and this is IGB, more photo for IGB. You see this is movable type of IGB where, sorry, IGB is shown here, where you can see the IGB how it controls the flow and pressure. If flow is if IGB is minimum open, then less flow will be there, less pressure rise will occur. If you want more flow, more pressure, then you have to open more IGB. Diffuser guide vane, that is called DGV. Diffuser guide vane DGV also controls the flow and pressure. DGV can be broadly three types. You can see this one type which is called fixed vane diffuser plate. It's a plate. This is plate. There is no vane, but this is plate. This is again fixed vane, but fixed vane. This is vaneless. There is no veins here, but there is a vane here. But again, this is a fixed plate. So fixed plate, fixed vane diffuser. This you see the veins are there, but this is fixed. Similarly, there is no veins here, but these are fixed. This is another view for this. But this is a movable vane diffuser where the veins can be moved. This some angle it can close slightly and open wider, and the function of this is used for control purpose. All are used for fixed position, but this is used for the control purpose, just like inlet guide vane control. Another device used for the compressor control is called ITV, inlet throttle valve. Typically it is a butterfly valve, but it can be ball valve, etc. Also you can see the photograph butterfly valve. So by opening of the butterfly valve or ITV, compressor is also controlled. You will get more flow, more pressure by opening more ITV. Now these devices I have discussed IGV, ITV and DGV. So these three controls are used for the compressor. IGV, sometimes IGV use, sometimes ITV use, sometimes DGV use, sometimes combination of any two or three are used. Now you can see in case of atmospheric air handling compressor, what are the possible control? One is either you can use inlet guide vane control, that is IGV, but please note that IGV is installed very close to impeller. Another control is possible as inlet throttle valve control, that is ITV. It can be installed far off from the impeller because in this case the flow is in axial direction, but IGV can turn the gas. Third is a diffuser guide vane control, which is installed on downstream of impeller, and IGB and DGB both control. So all four possibility or four type of controls are possible for air or atmospheric air handling compressor. In case of compressor which is used for the process gas, can be inlet guide vane control, inlet throttle valve control, diffuser guide vane control, or IGB and DGB both control, IGB and ITB both control. So all possible five types of control are possible for compressor which is used for the process gas. So I hope you have enjoyed the session. So thank you for watching.